Okay. Not quite sure what happened last time, but we are going live again, trying to get this sorted out. Had some technological differences. Let's see if we are workable. All right. I think we are doing the thing. So save. I think YouTube still looks live. Maybe. Okay. Maybe okay. It's a guess. Let me get my do-over. YouTube broke, but it's working now. Seems to be. And Rumble looks like it should be working too. Should be okay. Okay. Rumble like works better, but it's way less discoverable than you would like. Pretty much any time. That's the Rumble link. So let me Rumble link and YouTube link. All right. I think we're back sort of kind of okay. Posting links there. Kind of a bizarre. That was pretty weird. I think we're good to go now. All right. Ready or not, here we is. See if I can pull contract source from this. Should be able to. Okay. What I want to look at is the syntax for these tuples. It's a list of package code. Okay. I think that's one of the tuple syntaxes. So it'd be like bracket worker, comma worker is worker splat worker. I think that's how this works. I haven't done enough Sophia lately. So maybe this is what I need. Okay, so can I label these things? Split, transfer pack. Well, that's in the arguments list. Maybe it's just types. I think it's just types. It's going to return a list of that, and then bytes, and then a list of addresses. Okay, and we don't care who's calling this. We're going to return a... Ooh, okay, so worker, how do we actually form that at the bottom here? In this comma syntax, state IPs, state port, state salt, state IDs. I think that's it. We're going to find out in just a second. This is going to be barfing at me. Click deploy and get our failures. 410. Maybe I did mean state. Okay, 6.6. Do these need to be commaed? They probably do. They do. Okay. Unexpected token bracket. Okay, yep. This is me coming back to terms with Sophia syntax after a while. Yep. $16.40. Unexpected token. Blah. Yep. Okay. Ooh, we got a bunch of interesting ones. Contract owner. Where is... There's going to be a thing in the Sophia stuff that's like... what are the components? Creator, that's what it is. Contract creator. Okay, 3019. Now we're getting somewhere. Can't unify list address and int. Oh, of course you can't. Because that would be amazing if you could. I didn't change the type there. Ooh. Okay, we're getting somewhere. That all that was pretty fast. I'm not screen... Oh, my goodness, I'm not screen sharing. That's too bad because I just worked through all the barf points on this contract and fixed it, and it was so easy to do. And I wish I could have shown that. Oh, that's dumb. YouTube is working, but you haven't said anything interesting yet. Okay, look, this is what just happened. I went through like all these little barf points on my contract. Let's save real quick. All these little barf points on my contract. I had like I had state capitalized, for example. I didn't have commas at the end of this because I'd forgotten you can't just use the white space for it. Same thing here. And then I had bracket syntax instead of the type syntax. Just little stuff like that. Um, yeah. Whoops. Okay. Yeah. So anyway, I worked through those with these little things. So all this stuff here, this is all compiler feedback from when I click deploy. Like just for example, okay, I know that's wrong. So it's going to give me this. So 6.6. What I want to do is like the identifier port. Okay, why? Because this is missing. I want to highlight that that's it, and I want to put like a note above it, and I can do all that in Scintilla, which is what this text like interface is based on. And it's really slick, and I've got all the necessary feedback right here that I could like pop in and like highlight. And I haven't gotten to that yet in the Gajust thing. Anyway, if I click deploy, I get this, which is awesome. So I want to put what to form a list. I just write lists. Is that it? I think that's it. What is my list? What I should be able to just do localhost, right, for this to start with. And then port, I'm going to be on 7777. Salt. I don't know what's the byte syntax? I don't remember. I could just do empty bytes right now, or I could do a simple salt or something. Is there a bytes thing? There is a bytes thing. Bytes to integer. Is there a byte syntax to like type out a binary? It might be like a base 64. What's an empty byte thing? Bytes M, okay. Radio friendly. What's radio friendly mean? I'm getting a peanut gallery is acting up today. I don't know what radio friendly means. So I don't know what like a, is there a bits none, bits all, bits set, bits clear, bits test? Oh, I imagine that's like a location, like a flag test. We have a bytes 2 int, but we don't have a bytes int. I don't know how the bytes actually work. Oh, the coding process without showing it. Yeah, I didn't mean to do that. Feel slightly corny for having done that. Okay, so can we do a is it like that? I don't know, we'll find out. IDs. I think it's direct AK blah blah blah. I don't think it's quoted. Let's see, where's my let's make let's try 2 different keys. Or wait, was it like that or was it commas? I think it was commas. No, that was tuple. So it's going to be list. And then maybe it's a splat thing. Maybe that's it. I don't know. I'm going to put these into with too many things open. Oop, not that. I'm going to see what barfs, because I'm not confident that I've got the syntax right for these yet, these literals. That one especially. I'll have to ask Dimitar. He knows all these syntaxes because he's been doing all kinds of crazy contract coding lately. So just in case this blows up, I don't want to lose all that. Okay, so we're going to try to deploy this and watch what happens. Error 4, okay, IDs, unexpected identifier list. Okay. Same thing, bytes, okay. Is it brackets? I don't know what bytes is supposed to look like. Oh, through string to byte, like in the contract? I don't know what the bytes literal representation looks like. Whatever, I'll just try it naked like that and see what it tells me. Wrong type bytes any, already normalized integer. Okay. Wonder if blank works. No. I expected it into file. I don't know what a bytes literal looks like. Okay. We can omit the salt for now too. I would like to figure out how to get this to work. Do we have a string to bytes? Bytes to string? We don't have a bytes from string. Oh, we have a string to bytes. Maybe. Maybe we do. String to lower to upper at split contains tokens 2 and 2 bytes. We do. Okay. Converts a string into byte array. String is UTF-8 encoded. String length is not guaranteed to be equal to byte size. Yeah, sure. Because it's UTF-8. Okay, that's interesting. String to an integer. Okay. String to bytes. That's cool. So if I do that as a string, we'll just make the rule that we go. I actually like the hash version of that. Oh, it's a hash. That's its own type. I didn't know that a hash was a unique type. I thought it was just a binary. Keyword, blah, 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 escape, notation. No mention of hash as a type. Okay. String. int 2 bytes. Okay, well, I'm just going to find out how this works because I don't know. String. I'm really curious what's going to come of that. Because we'll be able to, on this lookup function, on the resolve function, it's going to show us like what the syntax looks like for binaries. And we may just want the rule to be that the salt is a string and that's it. And, you know, I mean, again, we don't even have to have a salt. I'm just providing it for the moment to see string to bytes, bytes. Okay. Okay, so let's try that again. 1313 on, oh, I need to what, include string, I think. Contract fund me. No, where's one of my include string, I think. Include string.aes, I think. Or the box namespaces are not that. Okay. String.aes. Okay. All right. So that'll be include. Include string.aes. And then string 2 bytes salt deploy. Whew, okay, there we go. We'll see what that looks like. Port salt string is going to be, I don't know, Frisbee, because those are fun. And then a list of addresses, which we had in some text editor thing. Not there. I have too many things to tab through. Oh, these two. And it was just like that, I believe. Deploy. Check deployment status. Checking deployment status. This probably blew up some crazy way, so we're going to check this transaction info. It'd be slightly funny if I selected a key that has no money. Oh, it has no money. I bet that's the problem. I bet it's... Yep. Okay. I'm dumb. I didn't realize that. I need to send like 1 Gaju to that account, and then it will be mined. There we go. So that's the thing that will catch you out all the time deploying contracts is you make a new account. It's the selected one. You just deployed it with this account that's got no money, and it's sitting in the mempool waiting for it to have money. Duh. Okay. So let's call resolve and just see what we get. What is the syntax? Oh, that's right. That's right. Dimitar told me about that. There's a like a hash syntax and then the bytes value. And we got, okay, this is really cool. So why am I doing that? I can just click copy and it goes to the clipboard, right? That's why I put a copy button there, specifically so I could do this. Okay. And I did this as, I did that way. And this was, the syntax was like that. Whoa, what am I doing? That's crazy business. Okay, localhost Frisbee. Why? Stop it. Kate's getting in my way. Okay, so it was like this. This is the syntax that I'm looking for. Okay. Now, this is workable. I don't know how to convert this to bytes that I want. How does that convert back to the string frisbee, I wonder? Is this what I think it is? Hang on a second. Oh, whoop. Okay, these are 2-letter escape codes for those values. That's how it converts it to a binary. So a binary string or a binary is going to be noted by a hash, and that hash is actually like this 16 hash and then stuff. And each different byte is a hex code point. That's how that notation works. So this isn't like, how in the world does this convert back to frisbee? But like, okay, now it's quite obvious how it does. That's because 6565 kind of set me off, and it's so close to 66, which is EF, right? I didn't remember that the hex codes for F and E were 66 and 65. I don't remember that kind of thing all the time. But that was a little bit suspect. So indeed, that is how it works. So if I do, look, $69, 73, 62, frisbee. That's what that is. Okay, cool. That's like super easy to understand. I just didn't catch on to it because I'm a bit slow. Okay. So how would we go about calling that on the chain? So the way that this would work is we have this contract ID. And that contract ID is effectively the name GajuExpress is pointed to by that contract address. Now, that contract address is about as hard to remember as an IPv6 name, sure. However, it's a single place that will always be pointing to that we can reference. Now, what we know we can do from here is in the contract itself, the contract creator is the only one allowed to update these values. What that means is that the contract creator key can be like independent of anything else in the system. It does not have to be one of the IDs, right? So you can have a key that no one's seen that deployed this contract, and that key can be held in cold storage somewhere, and that's the only key that manages this. Those public IDs, those can be on the server, and if any of those get compromised, the owner of this contract can revoke and replace those that fast. That is not something that you can do with the current certificate authority system. It's actually a pretty involved process to revoke keys like that. We could go a step further from this and actually make a self-signed certificate authority that is managed by either the deployment address, or we could have a list of certificates instead of a list of public keys. That's the easy one to do just to get started with, is we can just use public keys as the ID system. But that means that you have to have keys on the server, which you kind of have to have at some point. I mean, they could be fully ephemeral, or they could be connected to. I think we can. There's a way we should be able to use some of the mechanics of certificates to like eliminate the problem of the verification step. So we should be able to use fully ephemeral session keys purely without having public keys exposed on the server side. So even if the server got fully compromised, nothing would be lost. But the easy way to do it right now is to just start with this. But this is a fully trustless way like that. This is so short and it's so simple that it doesn't look like I did anything interesting. But the fact that I can, well, first off, the fact that I can stumble through writing a smart contract from scratch that does something like this, and like a little interface like this, and then I can just hit resolve and call it and check it out right now, that's crazy. Like, that's not a thing that exists in blockchain normally. But the way that this call works, and it results in this, this return data here, coming off chain like that, that means that anywhere in the world I could call this, and I could call that resolve function. And it will, it'll result in me finding out what network address I need to go to, what port number, a salt that I can use in the handshake step, and some public keys that like any key that the server side sends to identify itself should be in the list of authorized keys, so that as a client connecting to the service, I can tell that that's the case. So this is actually really, really cool. It was so like quick to write, and there's not much to it, that because all the hard part was just in getting a chain that works at all to begin with. This is pretty neat. So this is how I want to do the address resolution step in connecting to GajuExpress. So that way, if the IP address of GajuExpress changes, fine, I change that. The reference that we do know that never changes is this contract address. And that can just be in the GajuExpress client layer. And if we ever do change how the contracts work or whatever, fine. That's not a big deal. But this resolver contract can be used very flexibly by whoever deploys one to be used as a resolve point lookup. Now, there's a second step beyond this that I would like to do. There's no reason that we have to use this only for like, super special services, and we can't use this on the web. No, we totally could use this for web stuff. So we could make a local proxy. Let me draw this out with like ugly paint level junk here. So just imagine we had like so we've got our server, or we've got our local, like my browser. Actually, make it a little box. Okay. So I've got my browser, and it's Firefox, say. We've got a mess. The chain is a very scalable resolver database. It would suck as a session store. Yeah, absolutely. But this and access policy structures, yes. Yeah, exactly. So like the chain is not a good, like your live sessions and stuff, you wouldn't want to have like live, anything that's like really ephemeral, highly ephemeral, you don't want to store on chain, because highly ephemeral data sort of sucks to put on chain, and it makes the chain size grow, and it's expensive to store things on chain, and that sucks. So you wouldn't want to do that. But lookups, read-only lookups like this, like thousands of people can spam that resolve endpoint all at the same time, and your bottleneck is, well, if there's too much load on your nodes, just make more nodes because they just replicate so smoothly. So for stuff like this, it's like, as a lookup utility, it's really good. So anyway, how could we use that technique for web lookups? So the way like Tor works most of the time, or Freenet or whatever, if you have a local proxy that's here, so your little proxy guy, so this is your computer, and this is the internet, like the sort of space of doom, and this is a server you want to connect to. So this is like Nginx. You want to do a web request to Nginx. So normally Firefox steps outside of your firewall and it makes a straight request. So straight to Nginx, and then Nginx sends us back, and this is your your HTTPS. HTTPS. Okay. Now instead of using that, now this is the route where you use DNS. This is the route where you use TLS. This is where you set up a TLS tunnel, all that stuff. Instead of that, if we sent the request to localhost at a certain port, and then tacked onto the end of it what request you wanted to make to Nginx, this proxy could look up the on-chain name of whatever this service is, either with a contract thing or a name lookup. It could then call over to a proxy running locally here. So this is the other side proxy, using this specific tunnel technique, and this tunnel calling to this thing, the lookup would be to the chain and back, and then across to this guy over here. Then this guy can establish a route like that. And you can use inside of this channel, you can tunnel HTTPS requests or HTTP requests, whatever, web requests across to this guy and back up and down. But the tunnel itself, this proxy can validate or verify itself by the chain, the method on chain. And that tunnel is totally opaque to even a sufficiently well-connected attacker. So, and these lookups, as Ulf pointed out in chat just now, yeah, these lookups scale really, really well. So we can totally do this. This solves actually a really sticky problem in, the HTTPS kind of stack. Now, I guess one problem, this is called HTTPS. The other problem I've got is I don't know what to call this because I just made it up, and I'm really bad at naming things. So, I don't know what to call that. But anyway, this is like definitely a doable thing. We can make this alternative route. And the whole point in making a route like that is this proxy thing can eventually just go away. This is how HTTPS started originally. Like TLS was like a sort of secondary later. We can make that go away and make this talk straight to the server if we make a plugin. And that would be even better. We could make an Nginx and Apache plugin. We could make a QHL plugin. We could make a Cowboy plugin, and so on. We could make a kind of standardized plugin mechanism for this particular authentication method, and just completely sidestep. So like the result of that is, if you want to set up a website, or you want to set up a web service, or anything, you want to set up any kind of network service, what are the blockers? I don't have a static IP. Nothing works over HTTP anymore, so I have to have HTTPS. So I got to buy a certificate, or I have to set up Let's Encrypt, or whatever. And dynamic DNS kind of sucks, and so on. There's a whole like litany of reasons why people don't just set stuff up at home anymore, and it all winds up pointing back to like recent, get back to something centralized. Go just use AWS and forget about it. Okay, Ulf writes, the other hard problem you also got around was the security apparatus around the resolver records. As Sophia makes update protection trivial, and the data is immutable once on chain. Yes, exactly. So the certificate management over time, IP address assignment over time, port, even if you change port, whatever, when the owner of the contract calls IPs and updates the list of IPs, that's done right now. So you could automate that function. And you could make an additional key in here that's like the delegate. Instead of being the owner of this contract, you could have a delegate that's specifically only allowed to update the IP list, but is not allowed to update the IDs, for example. So you could automate. My point is, you can make your own dynamic DNS service, like out of this. That's kind of fun. Okay. And actually, this might be a place we could provide another service that's like a little tiny trivial micropayment provided service, is to do a dynamic DNS. It's not DNS though. Dynamic, whatever this is, service. Could be based on something like this. We could totally automate that. Yeah, we could totally do that. The thing that we would not want to do, that we wouldn't want to touch in the scope of an automated service at all, is we would not want to touch these IDs. That ID list needs to be managed by the owner purely. But address resolution, yeah, that's like a easy thing to solve with something like this. And like, this is way better than like this. Instead of having DNS as this one like ancient alien thing over there, and then TLS is this other thing that depends on the CA system that like nobody really trusts anymore or shouldn't trust anymore. And they're two separate things. This is just a single, like, how do you resolve a verified network location that's a service endpoint and verify that that location is what it says it is. And so that's one, the verification is one problem. And the other problem is, how do I find it in the first place? Starting from a name, how do I find the service? We can absolutely solve this. And it's a really cool way to do it. And the contract's really short. It's so short that it's going to disappoint some people that I know. They're going to feel compelled to write a much bigger one that has every possible feature in it. And that's fine. But this is where I like to start. I like to start with the little stuff. I would not like, I'm not going to start with the bigger version. The thing is, because resolve has no arguments, that's the only standard part of this that you have to have, actually, is resolve has to return like a tuple with these 4 things in it. Ooh, you know what I'm curious about? Okay. Let's deploy this again. And I'm going to provide an empty string and see what the binary comes out as. I have no idea. So IPs, we're going to have this time what? And those aren't really the ones I'm going to use. I'm just curious. I just want to see what the listiness looks like coming back to me. Port. Okay, so I try to connect to either one of those at port 7777. Also, this escapes the port problem where like HTTPS dictated what port it was. So did HTTP, unless explicitly provided. We can just have it be explicit every time, and you can just use whatever port you want, which kind of gets away from the like dedicated service port problem, which was sort of annoying ever since I was a kid. So string, a blank string, and then list of addresses. Let me get the, okay, so Alice has 2 Gajus and her is YMTGN. That's the one I'm going to deploy with this time. YMTGN. Okay, so that's the one we're going to sign with this time around. And we are going to use these keys again. Okay. Yep, deploy. Okay. Now in this case, if I dry run this, 0. Okay, that's cool. That's what I wanted to see, was like, what's the binary come out to when we have no like. That's what I wanted to see, is how that would look. So 0 is the null binary string. I guess that's 1 byte. Wolf writes, well, much of this is fairly basic blockchain stuff. Much of this kind of info wouldn't fit on a public blockchain. Yeah, Gajumaru's private associate chains. That's true. And not even private. Well, you want a lot of these to be public, not private associate chains. You want these to be public associate chains too. And like very public, because you want to look up services. But also for any kind of intranet management, you could use the exact same technique on a private associate chain. This is like a really kind of, well, we can let the economics of the situation kind of guide where this goes, but this is a tiny amount of data to store on chain. A couple of keys, a couple of IP addresses, a port number. This isn't much contract state to store on chain. You don't even have to store the contract source on chain, really, because you can just clone an existing one, which is I'll probably write like a utility to make that easy. Yeah, I could make a little site that does this. You go to a site and you say, I want to register my service. This is the way I want to do it. And once it's on chain, it's just on chain. The part that we don't have yet is we need to go back and like adjust the naming system a little bit to work the way that we want and be a little bit more flexible than it is right now. So that you've got some good, service namey, some good service names, and you want it to be natural. You want it to be a little bit more like domain names where people can have the name of a service, and that points to all this. And all you do is call resolve with no arguments, and it gives you what you need back. As long as it returns this quadruple, then you're good. We could work on expanding some types a little bit here. So these are all just like contract addresses, or I'm sorry, public keys. These are just addresses, chain addresses. We may want to have a different form of that, where instead of like, if these come back as addresses, then okay, you're going to have public keys. If these come back as like certificate strings, then okay, maybe the certificate string is what you're looking for. But regardless, some kind of ID. And yeah, so we can do these lookups programmatically without the DNS thing. Writing like a web, or not a web service, but writing a network service or a program that does lookups this way, does resolution like this, is really simple. It's just pick a chain endpoint to send your query to, and you'll get the stuff back, and then you connect to that and you just carry on. I have to get going. I got started really late today. I'm going to write out the client side and server side connection routine. I'd like to do that on stream because it's kind of interesting and it's not really complicated code. All the functions, there's like some stages to it, but the functions are all just named what they do. And it just lists like a pass-through. It's a pass-through routine. It's not very hard to do. I'm either going to write that on stream, or I might write it tonight off stream, but then like I could talk about it tomorrow. We could like go through the code together a little bit. If I'm able to get any programming done tonight, that's not a guaranteed situation, unfortunately. So regardless, this is a really cool idea. I'm going to like start a public repo somewhere with like Resolver in it. And then I'm going to make a sample app that's like the way that, oh, actually, no, we have a sample app, don't we? We have the GajuExpress client that's in GajuDesk. The server side for GajuExpress is really easy. I'll explain the server side connection part of it. And we can just talk through it. It's really easy the way it goes. So the trick the trick to why any of this works at all, this is the magic of the elliptic curve cryptography keys, is that if you have, ooh, I just put a thing there. So we have Alice and Bob, and Alice has a key, and her key has a private part, or well, she's got a public part and a secret part. Okay. And then we've got Bob's key, and Bob has a public half to his key and a secret half to his key. And the crazy thing is that Alice's secret key times, it's not exactly times, it's not really multiplication, but just it's kind of like this. Alice's key, secret key with Bob's public key equals Bob's secret key. You like my drawing with my mouse? This is horrible. I do this as a joke with people, and now I'm doing it on stream for reasons I do not know. But anyway, so Alice's secret key times Bob's public key equals Bob's secret key times Alice's public key. So Bob can give his public key to Alice, and Alice can give her public key to Bob, and they can do this mathematical function together, and they will get the same answer, and nobody else in the world can know what that answer is. They've got a shared secret, and they didn't share anything that is secret. That's super cool, right? Like, that's amazing. You can also, there's a way to mix keys together. So you can have like a public key that's known plus an ephemeral key you're just going to throw away. And you can merge those into a new key and then share that. And that still allows Alice to verify what Bob's doing, but Bob's actual session key is not going to be the permanent key that's the static key he uses all the time. So he won't have to sign with that for anything, but he can verify that he's got it in this kind of mathematical proof. And once that tunnel is established, since Bob is a service end, everybody knows who he is. Everybody knows his ideas. Alice, on the other hand, would connect with a key that she just made up just now for the purpose of this session, and she'll throw the secret away like immediately inside of the tunnel. Then she can identify herself, and nobody on the outside can figure out who Alice was that was connecting. Like, there's no public record of Alice connecting to Bob. There's just a public record of Bob having connected at some point to somebody. And we don't even know where Alice's lookup came from or went to, because it happened on chain, and nobody knows which chain node she even looked at to get a hold of Bob's information. So with no DNS and no CA, like, this is all very neatly, a very neatly resolved system here. So no need for DNS, no need for the certificate authority system, and we can do all this and make network services happen. I'm going to do this for GajuExpress, and then I'll probably write a web proxy as a demonstrator, and I might write a plugin for Nginx, but I have such a big stack of things I have to do, and I really need to get back to, like, top priority. I have to write Gaju Mobile also. So all these, like, the fact that there's so many different utilities that solve so many naughty, gnarly conundra that exist out in, like, the computer security world, which maybe you're being accelerated a little bit with, like, the Mythos release from Anthropic or whatever. This is absolutely the biggest, like, sort of nexus of probably next stage. I mean, value in computing, maybe, I don't know. It's a really big deal to get these things right. And unfortunately, it's a little bit hard to explain to people what the point of this is if they don't know how many moving pieces there are and what the moving pieces are. So you kind of have to write the thing and make it work. And then later, after the fact, they go, oh, that's why we can, that's why this is important. They won't get it until quite a bit later in most cases. So So explain the proposition. That's why I'm doing streams, is so that I can talk through the issues that are inherent to these problems. I did have a problem at the beginning of this particular stream. YouTube broke as soon as I mentioned the protocol that will no longer be named. But whatever, you can watch the first part of this on Rumble. It was kind of funny. The moment that broke was a little sus, but whatever. So I need to get going. I hope I can write out that stuff on stream. If I can't do it, I'll just write it out and then we'll talk through it maybe tomorrow or whenever I can. So anyway, that's where's my thing? Yeah. So this is really slick. I'll put this in a repo and start working on it from there and see if I can put maybe a demonstrator to it, like a ZX launch demonstrator where we have like a client and a server or whatever, or we just use GajuExpress as the demonstrator for it and move on from there. So thanks for watching.